Looking at some more examples in exercise 4F, or problems with the homework. Let's look at question 12J, and it says prove that cos of alpha divided by 1 plus sine alpha equals sec alpha times 1 minus sine alpha. So to know what to do here, we look at the right hand side, look at what you're trying to get. Now to get 1 minus sine alpha, you would multiply both the numerator and the denominator by 1 minus sine alpha. That creates a difference of 2 squares on the denominator. So we look at what we're trying to get on the right hand side, and that's how we know to multiply by 1 minus sine alpha over 1 minus sine alpha, because you can't just multiply by 1 minus sine alpha, you have to multiply by the equivalent of 1. So by multiplying by 1 minus sine alpha over 1 minus sine alpha, you're not actually changing the value of this, you're just changing how it looks. So it's like, you know, with fractions when you multiply both numerator and denominator by 5 or something. So then we end up with a difference of 2 squares on the denominator. We ended up with 1 minus sine squared alpha, which we know 1 minus sine squared alpha is cos squared alpha. So we replace 1 minus sine squared alpha with cos alpha. One of the cos alphas will cancel between the numerator and the denominator, so that will cancel with that, giving us 1 minus sine alpha over cos alpha. We'll break this up. So this is 1 over cos alpha times 1 minus sine alpha. And we know that 1 over cos alpha is sec alpha. Okay, you can write this as 2 fractions. For example, 5/7 can be written as 1/7 times 5. It's the same sort of thing. 1 over cos alpha times the numerator. Okay? So that's how you know what to do with that question. You look at where you're heading. Question 13C, x equals r cos theta sine theta, y equals r sine theta sine theta, and z equals r cos theta. Show that x squared plus y squared plus z squared equals r squared. So we're squaring each of these. This is x squared plus y squared plus z squared. Notice z squared does not have any common factor with anything else. So I'm just going to factorize the first 2 terms, and I've got r squared sine squared theta, bracket. So that's the common thing. Then I've got cos squared theta plus sine squared theta, bracket, plus r squared cos squared theta. So I look at the first 2 terms, and I can see that I have, you can't factorize the 3 together. So I can see I've got r squared sine squared theta, r squared sine squared theta is the common factor of the first 2 terms. And then I get cos squared theta plus sine squared theta. This is really good because that equals 1. So I've got r squared sine squared theta times 1 plus r squared cos squared theta. Now we can see r squared is another common factor, sine squared theta plus cos squared theta, which is r squared times 1, which is r squared, which equals your right hand side. To eliminate theta from this pair of equations, from the pair of equations. So this is question 14A. Now, we have to eliminate theta. Now, we know I've got a cos theta and I've got a sine theta, and we know that sine squared theta plus cos squared theta is 1. That's the only way we're going to eliminate theta. So what I'm going to do is rearrange both equations. So x over a equals cos theta. Are we okay with that? And y over b equals sine theta. Now we will square both. Why do we want to square both? Because we know that sine squared theta plus cos squared theta is 1. So we know that x squared over a squared equals cos squared theta, and y squared over b squared equals sine squared theta. This is squaring both sides, which we're allowed to do. If you've got something equals something, you're allowed to square both sides. Now we know that cos squared theta plus sine squared theta is equal to 1, so therefore x squared over a squared plus y squared over b squared equals 1. And I have eliminated theta from the pair of equations. All right, because we know we've got cos theta, we've got sine theta. If you see something like this, think of the Pythagorean identity, that cos squared theta plus sine squared theta equals 1. That's the only way you're going to get rid of any thetas. So notice my equation now does not have any thetas. 14c, we're eliminating theta from the pair of equations below. Now, we do want to get cos squared theta plus sine squared theta, so we just need to rearrange and take the 2 over. So x minus 2 equals cos theta, y minus 1 equals sine theta. We are going to square both sides, but be careful when you square the left, because what do? You get x minus 2 all squared equals cos squared theta, y minus 1 all squared equals sine squared theta. Now, I can expand now or I can expand later. I might expand later. Cos sine squared theta equals 1, and so therefore x minus 2 all squared plus y minus 1 all squared equals 1. Actually, I'm not going to simplify that, because you tell me what that is. A circle with center, so you would keep it in that form. This is a circle with center 2, 1 and radius equal to 1. So you would keep it in that form, because that form actually means something. I mean, or you could expand and get x squared minus 2x plus 4 plus y squared minus 2y plus 1 equals 1 and take everything over to the left. So the other way I could do it is go like this. So it's x squared minus 4x plus 4 plus y squared minus 2y plus 1. I'm going to bring this other 1 over. Minus 1 equals 0. We okay? And so then I could say that this is x squared minus 4x plus y squared minus 2y plus 4 equals 0, if I want to put it in that format. Okay? But I don't have to. Alright? It's actually good in that format. That the expressions are independent of theta. So we've got cos squared theta over 1 plus sine theta plus cos squared theta over 1 minus sine theta. What do you think you would want to do in that question? Independent of theta means get rid of theta. So we're going to go common denominator. So we've got cos squared theta, bracket 1 minus sine theta, plus cos squared theta, 1 plus sine theta, over 1 plus sine theta, 1 minus sine theta. So you will expand the numerator, and you'll get cos squared theta minus cos squared theta sine theta, plus cos squared theta plus cos squared theta sine theta, over 1 minus sine squared theta. Always do something on the numerator and the denominator at the same time. And then you say, thankfully, these cancel, don't they? So it's 2 cos squared theta over, what's 1 minus sine squared theta? Cos squared theta. And so the cos squared thetas cancel, and that equals 2, which is definitely independent of theta. And the next one that you can look at is prove that tan theta 1 minus cot squared theta plus cot theta 1 minus tan squared theta is independent of theta. So show that that is independent of theta. Now, this is not its. This is 1 minus tan squared. So I'd be writing my little expressions for cot squared, and so over the side, just don't get them mixed up. We know it's 1 plus tan squared theta equals sec squared theta. So you can do a replacement for tan squared theta, not 1 plus tan squared. I don't have 1 plus tan squared. So, or I can work out what negative, so tan squared theta is what? sec squared theta minus 1. Okay, and 1 minus cot, sorry, isn't it 1 plus little c? So 1 plus cot squared theta equals cosec squared theta. So cot squared theta is cosec squared theta minus 1. And we know tan theta is sine theta on cos theta. Or actually, we may not. We'll just see. See what you're going to do. And cot theta is cos on sine. All right, so that's what else we know. That tan theta is sine theta on cos theta. And we also know that cot theta is cos theta over sine theta. So that's what you need to know for this. And let's hope we get some cancelling or something that happens. Actually, or why don't you just expand? What about tan theta and write cot as 1 over tan squared? Actually, that's probably a better idea instead of this. I don't know. Let's have a look. We could go a few different ways. I don't know if this is going to... Why do we want secs and... I don't know. Do you want to try and... Yeah, I think so. Let's expand. So that's tan theta minus what? Actually, let's just write cot as 1 on tan. You want to do that? I think so. Times 1 minus 1 over tan squared theta plus 1 over tan theta times 1 minus tan squared theta. We'll just try this way. Remember, there's many ways you could do it. And then we'll expand. Is that okay? I think that's... I don't know. That just looks like I'm going to get into a big mess. It doesn't look like... Nothing's jumping out at me as, yes, this is great. Simple. I mean, it could work. It might work, actually. But let's have a look. So what do we got? Tan theta minus... Isn't it 1 over tan theta? This may not work. Plus... Oh, this is good. 1 over tan theta minus tan theta, which is 0. That was better. Because it's tan theta minus tan theta minus 1 on tan theta plus 1 on tan theta. Oh, that's definitely independent of 0, of theta. So, yeah, forget that. That would have been a nightmare. So, yeah, it just looked too complicated. All right? Cos of A minus tan A sine A over cos of A plus tan A sine A equals 1 minus 2 sine squared A. That's okay. What could you do? Look, it looks like we're going to have to do a conjugate somewhere, but what about tan? What's tan? If I go sine on cos, that does not, well, we could then multiply through by cos. Yes, I'm thinking. Let's do that. So, we're going to change the tan into sine on cos. So, that is equal to cos A plus tan A is sine A over cos A, but then we're timesing it by sine A. Sorry? Minus. Yes, minus. But then, aren't we multiplying that by sine A? Over, so that's sine squared A, right? Over cos of A plus sine A over cos A times sine A. Now, see how we've got denominators? Don't go common denominator. Multiply numerator and denominator by cos A. Multiply through by cos A. So, in other words, multiply the numerator and the denominator by cos A. Multiply, not through, let's write multiply each term by cos A. Well, that's numerator and denominator. You ready? What do you get? Cos squared A minus. What happens when you multiply this by cos A? Sine squared A. Cos squared A minus sine squared A over. What happens when you multiply this one by cos A? Cos squared A plus. And when you multiply this one by cos squared A, you get sine squared A. Do you see that or not? Now that's a good result because cos squared A plus sine squared A is 1. But we're going to replace, look at the answer.
1 minus sine squared A.
Yes, the answer's got no causes, so we need to change this cos. So, cos squared A plus sine squared A equals 1. So cos squared A is 1 minus sine squared A. So we're going to replace the cos squared A on the numerator, because look at now where you're going. You're trying to get 1 minus 2 sine squared A. There's no cos squared A's in the answer. You've got to get rid of the cos squared A. That's how you know what to do. So it's 1 minus sine squared A minus sine squared A over 1, which equals 1 minus 2 sine squared A. Okay? Learning a bit, aren't you? Equals right-hand side. We're discussing strategies to do A. We're not going to do it now. You'll do it for homework. What do you think you could do with the numerator? Factor out cos, factor out sine. You're going to end up with cos squared minus sine squared, whatever. You'll be able to, cos on sine that you factor out is cot, and I'm sure that some other things will happen there. I think you get 1 on the numerator and the denominator, and they cancel when you fiddle around with it, all right? That's just a strategy. What do you think you might do with B? Sec is, the only thing you can do with that is 1 on cos. Tan is sine on cos, common denominator. And cot is cos on sine, which I think you have to do. So these two will have a common denominator. That will have a denominator of sine, and it looks like you've got to then making a common denominator again. All right? So those should be okay. All right?